In this video, we're going to go over the concept of percentiles, quartiles, and box and whiskers displays, a way to describe your data when you have a skewed data, extremely skewed left or right. First of all, what is a percentile? So you decide as if you are looking at your data now in every 10% increase value. So for example, if you want to find the 10th percentile of your data, you use a simple formula. You substitute p by 10, and you would say, okay, my index is equal to 10 over 100 multiplied by the number of items in my data. This is the data of the household income. We had 12 values, so the n will become a 12, and therefore our first index is equal to 1.2. The rule says, which is rule number 1, if you get a number that is not integer, you round it up. In this case, 1.2 will become 2. And you go to your data that is sorted in increasing order, and you find the second item, in this case $11,070, the income of that specific house owner. So that's the value will be considered your first index that's located at the 10th percentile. The second index we are interested in is the 25th percentile, and this is a situation where you get a number that is integer, and the rule B says if you get a number that is integer, you look at the data that locate that number, the third location, 1, 2, 3, and you sum it to the one after it, the index plus 1. So you sum up 18,211 to 26,817 and divide it by 2, and you would say this is the number that represents the 25th percentile of my data, and the number is in that case would be 22,514. And you continue the theme. You calculate the 50th percentile, the 75th percentile, the 90th percentile. And you would say the following. The first percentile that represents the 25th of the percentile is called the first quartile. Not the first percentile, but what is called the first quartile. And the one that is located in the middle of your data, or the median of your data, we call this is the 50th percentile. And the third will represent the 75th percentile. So you can imagine what we are doing. We are trying to find what's going on in your data in quarters, from the first quarter, the second quarter, third, and the fourth, and the fifth. That's all what we are doing. So here's your data. And the rules for creating the 5 numbers summary of your data is to pick the lowest number in your data, which is the house income that equal to 7,524. We'll consider it your first point. We're gonna use as number 1. The second one is the quartile that is located on the 25th percentile, and this is the Q1, 22,514. Then you will take the median that is located at the 5th percentile, 50th percentile, and then you take the Q3, which is located at the 75th percentile, and the biggest number in your data will be considered the highest number, the 5th number. So let us look at how this box will be plotted. So this is a representation of the same data we were looking at. The smallest number is located at the bottom. The highest number in your data is located on top. In the middle, you will have this rectangle. The edges represent the quartile, first quartile, which is located at 25th percentile. The upper end of this rectangle is the quartile 3, which is 81,615, and the median is the one that represents the 50th percentile. Looking at this data in this way, you can tell evidently that it's a skewed data. So try to flip or rotate this image 90 degrees to the right clockwise and try to draw a histogram on it, and you would see that this data is skewed to the right. Imagine it like it's how it is skewed to the right. Okay, so this is a better way to summarize your data. At least you know the concentration of 50% of the population. Their income is between 22,514 and 81,615. That is a better way than anything else to represent the data. Another type of representing this data, what is called box and whiskers display, and I'm going to show it to you in Excel how you can plot those in a second after we finish the section. So what you do here, you subtract Q3 from Q1, so you will have the range size of your rectangle, and that will give you something called the interquartile range. The interquartile range. And what you're going to do with the interquartile range is you're going to use it to define the distance around your rectangle. Instead of using the smallest number in your data and the highest number of your data, you're going to use that to see the highest concentration of your data. And in this way, those big numbers like this one here will become as if an outlier. Something far away will not be as part of the equation that represents the household incomes for all people. So which makes big sense to me. Here is an example about one of the data set we have, which is the satisfaction rating for a DVD recorder. So we have the scale of rating came from 1 to 10. This is how people rated those rated that specific DVD recorder. We have 20 examples of rating being picked randomly by sample randoming by using a sample random function. And in this way, we can start finding the first quartile and the third quartile and the interquartile for this data. The same procedure we did with the previous one. Now, instead of using the smallest value 1 and the biggest value 10 as our upper limit and lower limit, we're gonna use the interquartile, which is in our case here equal 1.75. We're gonna multiply it by 1.5, and we will consider it how much far it is from the Q3, and we're gonna subtract it as well and from the lower value, and we were gonna see how those are far away from the interquartile box. So here is a better illustration for the same example. So in our case, we ended up with having the first quartile equal to 7.25, the third quartile equal to 9, the median equal to 8. Now, how you calculate the upper limit? You multiply it by 1.5 the range of this rectangle, and you end up with the upper limit. And the same, you multiply 1.5 and you subtract it from the Q1 to get the lower limit. In this way, as you can see in this data, 1 and 3 is considered outliers in our data. Those are no longer part of the description of our data. And again, if you plot a histogram, you can see that our data was skewed to the left, and in this presentation we were not affected by this skewness. We only considering these areas as part of the description of our data. Now the whiskers, those dotted line over here, how is calculated? The whiskers are after you find your lower limit by using the equation of the interquartile. This equation, quartile 1 minus 1.5 interquartile and quartile 3 plus 1.5 interquartile. So you have those two numbers here, 4.625, 11.625. So you have the upper and lower. Anything left in the data that is closer to this point, like in our data, if you look around here, we said 1 and 3 become outliers. However, 5 is the lowest number that we can see in our data. So the whiskers is going to end up at a point, the lowest point available in our data, which is 5. The upper area, 11, is the highest, 0.6, which is bigger than any of those scales. So the lowest number included in this data is a 10. So if we go back to our box to see what happened, here it is. So you have the 10 is the biggest number available in our data, which is less than the upper limit. So the whiskers stop here, and the other whiskers stop at the lowest number in our data, which was 5. And again, 3 and 1 were the lowest. However, they are considered outliers. They are less than the lower limit. So this is how you look at the data in a very nice way. So the satisfaction rating, as you can see here, was plotted Minitab, and we said we use Excel instead. You're going to see it how the outliers are distributed far away. So let us use Excel to help us plot those boxes. So first of all, I'm going to open it from a Windows machine perspective. So here we go. Let me open the design. Make sure you can see what I'm doing. So this is the rating, the bottle rating design. And in Excel 2016 in Windows, it's very easy to plot the box plot by using a chart. So if you go to the insert and click on this arrow here that gives you all the charts, see all the charts, so click on it. And from here, click on all charts, you should be able to see something called box and whiskers. So just click on that one and you should be able to see it and just say OK. So here we go, our data being plotted, and this is you can manage the look of it. This is exactly what we had from this chapter. If you did it manually, you will get exactly the same. So we have as rating, the upper limit is at 35. The lower is about 24, and you have those considered as outliers. The median is over here. The Q3 is at the 0.1, and this is the Q3. Q1, the first quartile, and the third quartile. And very nice representation of the data. And of course, immediately you can say it's skewed data and it's skewed to the left. Okay, now let us try the same but with Mac computer. So from Excel, you should be able to see this specific add-in feature. You click on it, and it's available for both Windows and Excel. So we'll see. If you need it, just let me know. From there, you should be able to see the descriptive statistics. And from the descriptive statistic, you can choose to plot the box plot. And you will say, OK, you have to pick the location of your data. My data is located at the specific places, so from here to the end. And that's it. In the time being, that's it. I can also plot the quartile and more, so we'll say OK. And as you can see, it gives you the box plot, similar to what Excel gave you as a chart display. And evidently, we have the first quartile, the third quartile, and the median. We have the outliers as well being mentioned over here, and that's a very good way to describe your data. So I would advise you when you do the exercises in your chapter to go over each one of them and try just to practice how you can plot the box plots and try to have an analysis of your data. Now, example 3.9 is very nice examples and shows you the comparison between different types of stocks that are available for us from the Standard & Poor's 500, and shows you a comparison if you want to invest in 1 year versus 3 years, the first figure, between 5 years versus 10 as the second, 10 years versus 20, the third one. And you can tell, for example, that you can see that there is a 25% chance of negative return, or what is called loss, for the 3 years horizon. And there are also 25% chances to earning more than 50% on the principal during the 3 years. So this is how you can describe the first plot. The second one, it compares between the 5 years technically compared to the 10 years of investment. And what you can see over here that if you the chances of loss for the 10 years horizon, it's evident. But the median return for the 10 years horizon is almost, you can say that it's double the principal, as you can say 100% return, which is about 8% per year compound. Now, where is the comparison between 10 and 20 of the horizon? There is you can say absolutely there is no chance of loss, and there were two positive outlying return that is over 1,000%, like almost 13% per year compound. So that's how you can use a box plot to compare between two different data sets in the same plot. My advice that you go into the exercises, try to answer them, and before the midterm exam, at least compare your answers to the solutions I'm going to give you on September 25th. Okay, that's it for this video. We will continue with the last video before midterm exam for section 3.4.